All right, everyone, this is part one of the exam review. I'll do the multiple choice on this one, and then I'll do the free response on a second one. So feel free to jump around as you need. Okay. So for this first one, measuring water in 2 containers. Remember, the key here is you're allowed to guess or estimate 1 digit more than is marked on the device. So you have one that marks every milliliter and one that marks every 0.1 milliliter. So for this one, you can mark it to the 10th place, so like 0.1. And for this one, you can mark to the 100th place, so 0.01. Then they ask you to add them together. Remember, when you add, you go to the weakest measurement. So you can report to B, the 0.1. Okay, so for the second one, we have sample chemical X, and they're giving us a breakdown of oxygen, carbon, nitrogen, and it predicts that a 17.5 gram sample would have how much carbon, right? And so it's basically like carbon out of total, right? And so the question is, how much carbon out of 17.5 grams total? Well, we know that we have 10 grams of carbon per, 20, 10, so 35 grams total. So you just set up a proportion, and if you do that, you should get just about 5 as your answer. That's the closest answer available. So bromine exists naturally as 79 and 81. An atom of bromine 79 contains what? So you go to the periodic table, find out that bromine is number 35. That means 35 protons, so automatically you're down to A and C. 79 refers to the mass, which is the sum of the protons and neutrons. And so obviously there's not 79 neutrons, so that eliminates C, so it's going to be A. Try to look for shortcuts like this in terms of your math. You don't have to sit there and crunch exact numbers. Just get an estimate. All the following are characteristics of metals except, so metals tend to lose electrons, not gain. If you look at all the metals that are going to be positively charged, loss of electrons, so D is the best answer for this one. And then which of the following pairs is incorrect? Looking at this one, we're going to say B, because there's 2 phosphorus atoms there, so we'd have to say diphosphorus. Everything else is correct. Remember, you don't have to say mono if there's one of the first element. Which of the following is incorrectly named? This one, there was a bit of a typo on the exam itself. Or not typo, but it got cut off. The actual lead got cut off there. So in theory, the answer is D here, because this is actually the nitrate ion, not the nitrite ion. Nitrite is NO2 minus 1. But I believe we did accept A as an answer because the lead was missing, so technically that was wrong as well. But yeah. Okay. The atomic mass of rhenium is 186.2. If 31% of it is 185, what is the other stable isotope? Well, clearly it has to be greater than 186, right? And so those are your options there. And so I think the best answer here is B, because if it's 37% of 85, that means it's going to be like 65% roughly of 80 of the other one. And so if it's 87 and it's 65% that, it's going to give us a little bit higher than 186, which is what it is. So that's the best answer there. And let's see. So this is the active ingredient baking soda. How many grams of oxygen are in 0.3 grams of the baking soda? So the correct answer here should be D. But there's a couple ways you could figure this out. But basically, if you figure out percent of oxygen, that's probably the easiest, right? You could say that there's 48 grams of oxygen per the total molar mass of baking soda. Not sure off the top of my head what that is, over the total, right? That's going to give you the percentage of oxygen in baking soda, and then you would just times that by 0.3 grams total, and that should give you 0.17 grams. Okay? How many of the following are true concerning the balanced equations? Okay? So I believe there's only one of these that are true, but let's walk through and figure it out, okay? A balanced chemical equation. The number of molecules is conserved. That is not true, right? I'll give you an example, right? So we could have like O2 plus H2 gives us H2O, right? And so you would need this. So in theory, there are not the same amount of molecules on either side here. So molecules is not always conserved. Coefficients of the reactants tell you how much of each reactant you are given. That is not true. The balanced equation is just a recipe. It doesn't tell you how much you start with. Atoms are neither created or destroyed. That is true, right? Atoms are conserved from one side to the other. The coefficients indicate that the mass ratios of the substance are used. No, coefficients are a mole ratio, not a mass ratio. And then the sum of the coefficients on the reactant side equals the sum of the coefficient on the product side. That is not true. Again, refer to this example here, right? Sum is 3 on this side and it goes to 2 on this side. So the only one that's true there is statement 3. Okay, on number 10, which is B, the limiting reactant, okay? And so you want to see here. So here it should be a 2-to-1 ratio of A to B, okay? And so we're looking for a scenario where there's more than double A, right? So in the first one, there is equal parts A and B, right? It's perfectly equal. So in this case, that's not going to be B, the limiting reactant, if they're perfectly equal. That would mean A is the limiting reactant, so it's not that one, okay? Number 2, okay, it looks like we have way more A than B. So in B, there's 5 Bs, and there's more than 10 As. So here, A is an excess, which would mean B is the limiting reactant. That is the answer here, but let's prove that the other two are incorrect. So for 3, right, we have 4 Bs and we have only 6 As. So A would be limiting here. And then we have 3 Bs and 6 As. So this is actually perfect ratio. Neither of them are limiting, or both are limiting, however you want to phrase that. And so that's not the best answer. The best answer here is 2. An unknown substance dissolves readily in water but not in benzene. What type of molecules are here? Okay, so if it readily dissolves in water, remember like dissolves like, water is polar. So the best answer here is that it would be a polar substance. Okay, so for this one, a 230 milliliter, this one was tricky. A 230 milliliter sample of 0.275 molarity is left on the hot plate overnight. The following morning, it's at 1.41 molarity. What volume of solvent has evaporated from the solution? Okay, this one almost got me at first too. It's the way it's phrased. How much has evaporated? So you're going to want to use the dilution formula. M1V1 equals M2V2. And we know that we started with 0.275 molarity. Okay, and we started with 230 milliliters of that. I'm not worried about sig figs here because the answers are very different, so sig figs are not going to matter. Again, save yourself some time. We go to 141, and we want to know what the volume of that is. Okay, X is, I believe it is the 44.9, so that's the trap answer. Okay, so what that number is saying is that you actually have 44.9 milliliters of that left. So that's not the question. The question was how much evaporated. So you started with 230, you're left with 44 or 45, right? What's the difference? So the difference is C. So if you picked A, on the right track, just kind of didn't quite read the full question. Okay, the following reactions are examples of what? So the key is that they are not representative of all the same. And so they're not all precipitation. They're not all redox for that. So you got to kind of go through one by one. The first one is redox. You have things going from elemental form into their bonded form. So their oxidation states are changing. So the first one is a redox. I mean, that by default should give us B, but let's confirm. B, everything aqueous except for 1, precipitation. And then C, You have an acid plus base gives you water and salt. So that's an acid base. So B is the best answer there. Okay. Aqueous solutions of potassium sulfate, sodium nitrate are mixed together. What statement is correct? Okay. So basically they're trying to figure out, is there going to be a precipitate? So remember, the new products would be potassium with nitrate, sodium with sulfate. If you remember the solubility rules, you don't have to remember all of them, but remember the go-tos. Nitrates are always soluble, always. So this is wrong, okay? This is wrong, okay? Then everything with group 1, the group 1s are going to be soluble. So sodium sulfate is going to be soluble. So no reaction is going to occur, okay? Gas sample is held at constant pressure. It occupies 3.62 liters when the temp is 21. Determine the temp at which the volume of gas is 3.43 liters. You must convert to Kelvin. The gas laws only are true when you are in Kelvin. So if you remember, we're relating volume and temperature. V1 over T1 equals V2 over T2. Okay? And so you just have to plug in here. Okay, so you have 3.62 liters over 21.6 plus 273. So 29 or 294.6. Okay, equals 3.43 over x, and you solve for x, and you should get 279. Okay. The other way you can look about that is you actually don't need to do the full math if you simply convert to Kelvin and realize that your initial temperature is like 295, then you can just ballpark it because the answers let you do that. Because if volume goes down by a little bit, temperature is going to go down by a little bit. And the only option that gives you that is B, right? So A is out of the question because it's not going to go up. C is so small, that's ridiculous. And D is the same, in other words, unchanged. So the only obvious answer is B. So you actually don't have to do the full math here. Again, look for ways to save yourself time. Okay, if you add the same mass of neon to a container of helium, which describes what's going to happen, temperature is constant. So that's key, okay? So you add its mass, right? That's the key here, is you're adding the same mass. Okay, if you were adding the same moles or molecules, this would be a different answer. Okay, but you have the same mass of helium. Okay, so if you had 10 grams of helium, you're adding 10 grams of neon. Okay, so the pressure in the container doubles. So that's not going to happen. Helium and neon are very different in masses. If you were adding the same moles, that would be the correct answer, but you are not. Okay. The pressure in the container increases but does not double, okay? So pressure in the container increases. The pressure is going to increase. That is true, okay? And so they tell you are in a rigid container, so volume is not changing. So the question is, does the pressure increase but not double, or does the pressure exactly double, okay? Or sorry, more than double, okay? And it is going to be B because neon weighs more than helium. So you are not doubling the molecules. You are less than doubling the molecules, okay? And therefore the pressure should increase by less than double. Okay. So this one, given a cylinder of fixed volume, which of the following is correct? So I think the best answer here is D, none of the above, but let's go through it and make sure. So if the temperature of the cylinder is changed, the pressure will double. No, this is the trap. It's Celsius here. It will only follow that rule if it's in Kelvin. So that is not true. That is a classic AP trap question. If a second mole of argon is added, the ratio would remain constant. Okay? That is not true. Okay? A cylinder of identical volume filled with the same pressure of helium must contain more atoms of gas because helium has a smaller radius than argon. Okay? This one's tricky because helium does have a smaller radius than argon. Okay? But you have to understand what it's asking you. Okay? if it's the same volume filled with the same pressure of helium, it must contain more atoms of gas because helium has a smaller radius, okay? So you got to think PV equals nRT, right? Okay? It says it's a fixed volume container. Volume's constant, okay? It says same pressure, okay? So if you add, okay, another, right, given a cylinder of fixed volume with 1 mole of gas, what's correct? Mole is constant, right? Okay. So C is not going to be true, right? So none of these are going to be true. And that's just based on the ideal gas law, right? PV equals nRT. Okay. Okay. Oh, and back to part B, just to kind of clear that up, right? The reason why TP would not remain constant is because they told you that volume, so if we have PV equals nRT, they told us that volume was constant, right? And they told us moles changed. Well, R is constant. So the PT relationship has to change here. Which of the following frequency corresponds to light with the longest wavelength? So remember, frequency and wavelength are inversely related. So longest wavelength, okay, largest wavelength, we're looking for shortest frequency. So we're looking for the smallest number here, which was B. Okay. So for this one, when a hydrogen makes a transition from 3 to 1, which statement is true? So that's like when we have the energy levels, right? And the electron's out here and it drops to here, okay? If it goes from 3 to 1, which is true? Okay, so energy is lost, okay? Energy is lost. And so energy is going to be emitted, okay? So it's not going to be absorbed. The electron is going to lose energy, right? Because it's going down in energy, so it's not going to be gaining energy. And the electron cannot make this transition. That's not true. Of course, electrons can make that transition, okay? So the best answer is going to be B because 1 and 3 are true statements. Okay, so which best describes an orbital? It's the space in an atom where an electron is most likely to be found. Okay, that's just a definition. You kind of have to know that. How many F orbitals have the value n equals 3? This was kind of a trick question, okay? So n equals 3, right? So remember, n equals 1, there's only one type of orbital, s. n equals 2, there's only 2 kinds of orbitals, s, p. n equals 3, there's only 3 kinds of orbitals, s, p, and d. You don't see F until energy level 4. So it is not possible to have an F orbital of any kind in that energy level. Now, if it said how many F orbitals have the n value 4, you would say 7. There's 7 F orbitals in n equals 4. All right, element E has this configuration. The formula for the fluoride of E would be what? Okay, so you're going along 5s2, 5p2. Okay, so that's going to put you in group 4, which means that it's going to want to bond 4 times, right? It's got 4 more spaces for electrons. It wants 4. Fluoride wants to give away 1. So the combo there, you're going to need 4 fluorines to make this a compound. Which of these has the lowest first ionization energy? Remember, the trend for ionization energy is up and to the right, okay? And so you're looking for something kind of down in this area of the periodic table. That best answer there is going to be barium. Okay. Atoms have equal or nearly equal electronegativities are expected to form non-polar bonds. Okay, remember, polarity comes from an unequal, okay, connection there of electronegativity. Which of the following molecules contains a double bond? You could just sketch these out, if you just kind of know, right? CO2 definitely has double bonds, so you could just stop right there. CO2 has double bonds. Okay, NH3 and H2O definitely don't. But if you weren't sure, because all of these, right? If you just remember, hydrogen can never form a double bond, And so by default, B and C are not going to be your answer. Okay. In 26, the hybridization of the central atom in ClF2 plus is what? And so you could just quickly sketch this out. Remember, valence of chlorine is 7, fluorine is 7. There's 2 of them, and then we're going to take one away because of the plus charge, right? So that means we have 20 electrons to work with. We're going to put chlorine in the middle, the F's on the outside. We're going to connect them, right? 2, 4, 6, 8, 10, 12, 14, 16. I need 4 more. That means there's going to be 4 domains of electrons around the central atom. 4 domains means sp3. The best Lewis structure for acetone. This one was a little tricky, but really we're looking for formal charges. So you're looking for best option that's going to give everybody 0 formal charges, and then just kind of keep the molecule kind of symmetrical there. So the best answer here is this one here. That one gives you everybody a 0 formal charge. Everybody's bonding the way it wants to bond. In this one, the oxygen has a positive and the carbon has a negative, so that's not ideal. In this one, the carbon has a negative, okay, and the hydrogen is bonding twice, which is not cool, okay? And then in the last one, again, you have hydrogens bonding twice, which is not going to happen, and then carbon is missing some electrons, so that's not going to happen, so B is the best answer there. Okay, 28. So helium has a much lower freezing point than xenon, and they're both noble gases. Which statement is supported by this data? This is a good example of sometimes they say true statements, but they don't answer the question. Okay, so A, they form highly polar molecules. Definitely not true. Noble gases have very, 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 very low electronegativity. As the molecular weight of the gases increase, freezing point decreases. Okay, well, then that would say that xenons should be lower, which that's not what the data says. So that's out. The London dispersion forces between helium are greater than between xenon. So if it has greater intermolecular forces, the freezing point would be higher. So that's not true. It's the opposite, which is what D is saying, right? Okay, salt sits in an open beaker. Assume constant temperature and pressure. The vapor pressure of the solution, what? I think the best answer here is decreases over time. Okay, so remember the colligative property is vapor pressure lowering. So increased moles of solute equals lower vapor pressure, right? And so what's going to happen if a salt solution sits overnight? Water is going to evaporate. So if water evaporates, the concentration, right, or I shouldn't say moles, it's molarity here. So if the molarity of the concentration increases, then the vapor pressure is going to lower, right? And so B is the best answer. Molar mass of the solid is determined by the freezing point depression is 10% higher than the true molar mass. Which experimental error could not account for this discrepancy? So you're looking for something that would have caused your mass to be lower than the true molar mass. That's what they're asking for here, right? So 3 of these should cause it higher, okay? And so that's what we're looking for here. So if you remember the freezing point formula, delta T equals K molarity I, right? And then you also remember that molar mass is grams per mole, right? So if you're looking at this, okay, the molar mass of the solid is determined, depression is higher than the true molar mass, which would not account for that. So to get it to be higher than the true molar mass, right? Okay, so if the molar mass is higher than the true molar mass, then you need fewer moles, right? Here, right, moles would have to be smaller to make this fraction bigger, right? So smaller moles would indicate 10% higher. So what this question is asking you, which one would do the opposite of that? So we're looking for the one of these errors that would cause the moles to increase. Because if moles increases, this fraction decreases, okay? Okay, so if not all the solid was dissolved, that would be less moles of stuff. So that's not going to be it. More than the recorded amount of solvent was pipetted. So if there's more solvent, there's less mole, like it's going to be a less molarity of substance, so then lower moles, okay? The solid dissociated slightly into 2 particles when it dissolved. Well, if you were assuming that I was 1, but it actually was like 1.5, then that would actually give you a false sense of what your moles were, and you would think that your moles was higher than it actually was. So this one should track, okay? Some solid was left on the weighing paper. Well, that would be that would cause the molar mass to be higher than the true molar mass, right? So that would again be not the best answer there. So C is the best answer there, okay? So if some solid was left on the paper, you would think that your original molar mass would be larger than what you originally thought. So, okay, in 31, which of the following is an electron configuration of excited atom? So you're looking for somebody that has an electron in a higher energy level when the one below it is not quite filled. So this looks like it's in the right order, okay? This one's in the right order. This one, there's a space in 1s1 still, so that one should be there. So that one's definitely in the excited state. This one is not, so that's the best answer there. Okay. 10-gram sample of this is dissolved in water and an excess of HCl is added. Its precipitate is formed and placed in the oven to dry. Final mass is significantly greater than predicted, which could account for the discrepancy. So you're looking for an error that would account for a over 100% yield. Most common reason for that always is it's not dried. And they even gave you this here. It was placed in an oven to dry. Okay, so I would say the go-to default answer is that it's not dried or not dried to constant mass. So I think that's the best answer. But just to prove it, if some precipitate spilled out, that would give you a lower than 100% yield. If PbCl2 is only slightly soluble, okay, then that would give you, again, less yield because some of it would have been dissolved. Okay, and then a 3 molar solution was used instead of 1 molarity. Well, HCl was in excess, so adding more is not going to affect it, right? That was a key there. They made a point of telling you that HCl was in excess. Okay. Diagrams below represent 2 different aqueous solutions before they were mixed, which is the best particle representation of what happens. So the first thing is what happens, right? You have 2 aqueous things. So we're going to have sodium going with nitrate, silver going with chloride. Are we going to see a reaction or a precipitate? The answer is yes. The silver chloride will precipitate. Sodium nitrate should remain aqueous, which means dissociated. So A is out of the question because it's showing you both compounds are stuck together. No. Same thing with B. Both compounds stuck together. No. Okay, so now we're down to the last 2. In both of them, they're showing you the AgCl stuck together and the NaNO3 separated. What do you know about solids when they're in liquids? They are more dense, so they're going to settle to the bottom. The best answer is D. Okay, you had to show it's going to be separated in real life. Even though we write it in the equation like it's not always, it is going to be in real life. Okay, and the last couple here. Choose a solution that has the highest boiling point. Remember, boiling point elevation. So you're looking for the one that's going to have the most moles of solute dissolved. They all have the same molality. So then it goes to the I value. Are the I values the same? If the I values are the same, then D would be correct. The I values are not the same, so D is not correct. You have an I value of 2, an I value of 3, and an I value of 1. So if they're all the same concentration, I value of 3 is going to always win out, and that's going to be the answer there. And then what would you record the volume of the liquid to be? Remember, you always can guess one more digit than is marked on the device. Okay, and so the best answer here would be 27 because every 10 is marked. So you can guess every 1, which would be 27. So that is